All right, class, I'm going to do a few examples from 21 through 29. These are the problems where finding the distance between parallel lines given equations. First problem we're going to look at is 21. 21 has y is equal to -2 and y is equal to 4. Let's plot it so we have an idea of what this looks like. These are two horizontal lines, we know that. So that's y is equal to -2 down 2. That line looks like this. Count up 4 for y equals 4. 1, 2, 3, 4. That's y equals 4. This is an obvious distance of 6. Okay, you can just count that by drawing it. You see that these are both horizontal lines. The distance is equal to 6. Is there any work to show for this? The illustration shows it. Next problem. Let's look at something else a bit more difficult. Let's look at 23. 23 is more the type of problem that you're going to handle. 23 and 28. So 23, I have y is equal to 5x minus 22, and y is equal to 5x plus 4. Again, a quick sketch. We're going to have to compress some things. It says -2, -22. So let's say that that's 10, that's 20, and that's 22. So that's where it intercepts at -22. That's your y-intercept. Very important information. We'll use it later when we're finding the distance. Now I'm going to say it's a positive slope, so I go over 1 and up 5. We're estimating this, okay? This is a drawing to help us think. So that's the line y is equal to 5x minus 22. The next line is going to be plus 4 for that y-intercept. Plus 4, so that was about 10, so that's going to be about 4. These are estimates. Imitate because it's parallel to this. That becomes my sketch. I know that I'm finding a perpendicular distance. That's the important distance. Why am I choosing this point? Because I already know this point. In order to find distance, remember what distance formula is. Distance formula is distance is equal to the square root of x1 minus x2, x2 minus x1, it doesn't matter, squared, plus y2 minus y1 squared. In order to find distance, I need points. I already know one point. What is that point? That's the point 0, 4. It's the y-intercept. Let us find the point that's perpendicular to this point, okay? In order to do that, we're going to define this line, the perpendicular line passing through the point 0, 4, that also intersects this other line defined by that equation. This will have 2 points, then we can use the distance formula. How do we define this line? How do we define the perpendicular line? What's the y equals mx plus b for the perpendicular line? The slope we know because of the relationship between perpendicular. Negative reciprocal. It has to be -1 over 5. That has to be the equation of the line. How do I solve for b? As always, you pick one known point on that line, 0, 4, where x is 0, y is 4. So 4 is equal to -1/5 times 0 plus b. It's always going to work out this way, where b is equal to 4, okay? Not where b is equal to 4, where the m times 0 goes away if I'm using the y-intercept, okay? So now I have the full equation of that line. It is y is equal to -1/5 x plus 4. I'm trying to find out where this line intersects with the second line, where y equals 5x minus 22. When do these intersect? Well, it intersects over here, but where's over there? Let's set these two y's equal to each other. So -1/5 x plus 4 has to be equal to 5x minus 22. Get all of our x's on one side, all of our numbers on one side. Add 22 to get rid of a subtraction of 22. Add 22. I now have 26. I still have the negative 1/5 x plus 26 is equal to 5x. Get the x's on that side by adding 1/5 x plus, sorry, that's not necessary. Add it to this side, 1/5 x. That becomes 26 is equal to 5 and 1/5 x. 5 times 5 is 25, plus 1 is 26. So this is really 26 over 5. So 26 is equal to 26 over 5x. How do I get rid of multiplication? By division. I'm dividing by 26 over 5. Dividing by 26 over 5 is the same thing as multiplying by the inverse. So I multiply it by 5 over 26. What did I say? Dividing by a fraction is the same thing as multiplying by its inverse. Do the same thing on both sides. 26 cancels, and now, because of course this cancels that cancels that, that's why we did it. 5 is now equal to x. Knowing that 5 is equal to x, I can find my y value by plugging this into either of the original equations. Actually, I'm going to plug it into this equation, the equation of the perpendicular line. I'll do this work over here, because we're running out of a bit of space, and I will say y has to be equal to negative 1/5 x plus 4. We found that x is 5, plug 5 in. Y has to be equal to negative 1/5 times 5 plus 4. Y has to be equal to negative 1 plus 4. Y has to be equal to 3. These are not my answers. This is my coordinate. I have two coordinates now. One point, that point is 0, 4. This point has been defined. I now know that that point is 5, 3. I now find the distance between 0, 4 and 5, 3 using the distance formula. This is the parts, I'll just set it up for you instead of getting the answer. It's going to be the square root. We'll label these points x1, y1, x2, y2. So it becomes 5 minus 0 squared plus 3 minus 4 squared, the square root of that. That's 25 squared, sorry, not 25 squared. 5 times 5 is 25, it's not squared. 25 plus 1, the square root, is equal to the square root of 26.